new infrastructure for analytics. So that is, take all of your data out of your operational database, be it Oracle or Couchbase, whatever, and then put it into, say, HDFS. Who here is like who would classify themselves as like building operational applications versus analytics, like business intelligence, things like that? Who is operational? Websites, apps. Who here does more like analytical things? So who's a Hadoop user? Some of you are not either. I'm not sure what you guys do. Anyway, so let's say that you built this big operational system, and now you just want to do daily reports. Now, where I worked previously, this is exactly what we did. We pulled all of that data out. We put it into HDFS. We ran MapReduce on it. Okay? Tens and tens of more computers, a whole new department, hiring a bunch of new people. However, if that's what you want and you're using Cassandra, then you can actually say, no, I'm going to segregate these nodes, and I'm going to do my analytics directly on those nodes with no kind of ETL, extract, transform, and load. And you can do this with MapReduce, but we're going to talk about doing it with Spark because it's kind of taken the analytics world by storm, no pun intended. So, that's bad, wasn't it? I'll use that joke again. Okay. Right, so conceptually, same as Hadoop MapReduce. Okay? However, it's modern. It keeps a lot more things in memory. Okay? And one of the reasons it's a lot faster is, let's say you want to have a multi-stage job of mapping, lots of transformations, followed by some filtering. Okay? It won't do anything until you actually decide to say, save it to disk, or put it in a database, or write it to a queue. So it can basically work out the most efficient way to do it. Whereas in a typical kind of analytical framework, as you write those separate stages, they'd get written to disk in between, and they'd be very slow. So the main components of Spark, okay? I'm not a Spark evangelist, I just think it massively improves Cassandra. Okay, so Spark is not a database. It needs data from somewhere, okay? Traditionally that's been HDFS, right? But I'm saying if your data's already in Cassandra, then you might as well run Spark directly on top. And if you want to write things in the Spark execution engine, which is this area in the middle here, that's where you'll be writing code, okay? You'll be writing Scala or Java or Python, and I'll show you some examples. However, if you want higher level abstraction, so let's say we're doing some type of reporting, then you can run SQL on it. Now, there weren't too many Cassandra actual users here, but you know you can't join in Cassandra, right? It's a distributed database. Joining would be slow. If Cassandra let you join, they'd be telling you to screw yourself over essentially, because it's always going to be slow. However, if you need to do a join for an analytical reason, then that Spark SQL can do it for you. The other thing that we'll look at today is streaming. So this is rather than doing analytics on a big set of immutable data, let's say what our customers did for the last day. We actually want to start doing some of these statistics and aggregation as the data comes in. So Spark streaming can be think of as, say, equivalent to Storm. But the great thing about doing it with Spark is you're going to be using the same programming API. You can almost reuse the same code for your batch analytics and for your streaming. So what does a Spark architecture look like? So essentially, it's going to allow you to run large computations over large sets of data. So hopefully you've got more than one computer, right? And for each of those servers, you're going to run a Spark worker. And in the examples we'll show today, we're going to run Spark workers directly on our Cassandra nodes. So we're going to co-locate them. Okay? All of these workers will be managed by something. Spark has a built-in kind of cluster manager that you can use. But if you're already using, say, Yarn or Mesos, then you can continue to use that. And then you've got your driver. So a lot of the people who are using Spark on top of Cassandra, you actually get a repl. It's like a shell, and that's your driver. Alternatively, you can submit, pre-built package applications to it, and we'll show both. So the main programming API in Spark is what's called an RDD. Has anyone written code in Scala before? Got a few Scala, but you'll recognize this. These look just like Scala collections, but they also look like the collections of any language which have a functional mindset. So you're going to be able to filter these and flat map them and things. Okay? The big advantage, I think, of doing it this way is programmers are very familiar with them. As soon as you start using it, if you've used a collection in Scala before, there's no training required. Okay? The difference is, these are actually like representations of vast quantities of data, either say in Cassandra or in a file system of some description. The kind of things you do to them, I've already mentioned, we map, we flat map, we filter, we transform, we group by, those types of things. However, none of that gets executed. We're not actually going to touch the Cassandra database until you do what's called an action. And an action actually says, stick it in a file, write it to a Cassandra table, something like that. Then Spark works out the most efficient way to execute it, and off it goes, and it uses all of your worker nodes. That's a lot of words. Let's have a look at some Scala code. So, you can't talk about analytics without word count, right? So I have to show you word count. It's on, essentially, who's written word count in Hadoop? In MapReduce? Okay, slightly nicer. So essentially here, we've only got a few lines of code. We're loading a large file. We're then going to, flat map and split it. It's going to split out each of the lines. Then we're going to map it into a count of each word to 1, and then we'll reduce. And then we can write it back to the file. And I'll show you a Cassandra word count soon, which is even more exciting and stuff. But one of the big advantages of Spark, the reason that developers I talk to tend to love it, is this, the repl. So when you just want to get going, you can literally just download Spark, you can run it in local mode, and you could like copy and paste that code, okay? You don't even need to get the file from HDFS, you can get it from a normal file system, and you can start playing with it right away. The other main advantage I find is this. So we mentioned streaming, but essentially, we've already kind of covered this, but we're going to take data of any form of stream. So a queue, a socket. You can't stream out of Cassandra yet, but there are, if you follow the Cassandra Jira and the Spark Jira, there are talkers of doing it. You can stream data from Twitter. All that essentially does is, rather than dealing with one big file or one big data source, we take a stream of it coming in and we chop it into little bits. And then that same code, that flat map, I'm going to show you a network word count, a streaming word count. But the same code just operates on tiny little chunks. So that's kind of a Spark overview. Let's now actually see how the two work together. Okay, so I'm not a Spark salesman, I'm not any salesman, all this stuff's free. So the guys at DataStax have open sourced a connector between the two. So right now it's on GitHub, you can go and grab it, and it does the magical thing of it turns a Cassandra table into an RDD. So you can essentially do analytics. It's like doing a full table scan in Cassandra. And if you're using Cassandra at scale, which you probably should be if you're using Cassandra, then those tables can be terabytes and terabytes. Okay? But what the connector will do is make sure, if we put our Spark workers directly on our Cassandra nodes, it's going to do as much processing as it can locally. And we'll see the advantages of that. So we'd set it up like this, we'd segregate a few of our Cassandra nodes to be the analytics guys. We would not let our website talk to these nodes or our application. They would stay to the orange ones, and that would get asynchronous replication. On each of those nodes, we'd run a Spark worker. Okay, so orange is Cassandra here, blue is Spark. They'd be right there. And the connector's clever. It connects to the Cassandra node, and it works out which one it's sat next to, works out which data that node owns, and then does local processing there before it brings it back to your driver application. But I'm a big fan of examples. So let's see some examples. So all the things I'm going to show today are on my GitHub. The Spark connector is on GitHub, so you don't have to be a DataStax employee to get contributing. If you like Scala and you like hacking and things, go and get going. So if you've used Scala before, you've probably heard of SBT. So all the examples I'm going to show you today, you could copy and paste them into a shell. But because I put